ChatGPT or whatever. So basic thing is such as X-shot learning. For example, zero-shot means there's no example to the ChatGPT or whatever, and then one-shot means there's only one example. Few-shot means there are several examples to the GPT model. Okay, and then there are also some widely known techniques of prompting, such as COT, chain of thought or whatever. And then also, when you use the prompt engineering, we have to be aware of some limitations, such as hallucination. Hallucination means sometimes the generative AI models, such as ChatGPT, GPT models, provide some false information. We need to understand that kind of limitation of the recent model of ChatGPT, the GPT models, or whatever. The other decoder models. And then also, now let's move on to the previous papers about the prior studies about the interrelationship between human language models and computational models. The first one was this one, language model behavior. In this case, the literal meaning of behavior means ChatGPT, the language models such as BERT, GPT, they can be used as a kind of non-human subject in the behavior studies of human languages. Okay, so this one, and then so LLM can be regarded as non-human subject in linguistic studies. Okay, and then so there are several ways of using larger language models for psycholinguistic studies, and then there are some pros. For example, this one, LLMs makes possible to conduct cross-linguistic analysis. In psycholinguistic studies, if we compare some cross-linguistic evaluation, some cross-linguistic result, we have to recruit the different types of native speakers. But if we use the large language models, we do not need to recruit all different types of native speakers at the same time, even though there's some weak point in the evaluation result. Okay, so in this case, that kind of stuff would has its own pro. Okay, and then this one. Personally, I really love this paper, real life paper. So this one, the Nathan Schneider at the Georgetown, he raised focuses on this kind of stuff. So the main idea is how linguistic theories can be used for improving NLP systems, including large language models. There are 6 items. So hence the acronyms realize. The first one is resource. The second one is evaluation, low resource settings, interpretability, explanation, and finally studyable language. That means the linguistic theory are still quite important, at least for evaluating and improving the large language models. If you have time, I strongly recommend you to read this paper. Okay, and then this one. The title is a little interesting. Language models as models of language. Okay, so the same goes for this one. So we can make use of large language models as a kind of non-human subject in the linguistic studies. That means, so building upon the large language models, the question is, we can test the human language competence and performance at the same time. But there are some, as I said, there are some problems. There are some problems in using large language models for linguistic studies. We should be aware of that kind of weak point in advance. Okay. So basic thing is they can be used for behavior studies, probing studies, and interventional studies. but we need to understand there are some gap between the human language models and computational language models. Okay, so in this case, we also have some expectation for cooperation between theoretical linguistics and computational researchers. Okay, so I think this room is also that kind of stuff. It's also that kind of stuff. Some kind of interrelationship, some cooperation between the two different groups, theoretical linguists and then computational researchers. Okay, and then the large language models would be a kind of foundation for that kind of a cooperation. Okay, and then this one, large linguistic models rather than large language models. So this one means we need to understand the cognitive approachability of large language models via throughout some language experiment. Okay, so as I said, there are several weaknesses in using the large language models in the linguistic studies. Most of them, this one. Large language models fail to replicate human development process. That means they do not have such a sufficient underpinning of cognitive process in terms of language development. Okay? So again, there are several opportunities of using large language models for linguistic studies. Amongst them, I wanted to really focus on this one. Invasive experiment that would be almost impossible to perform on humans. For example, it is almost impossible with human subject to conduct a language experiment consisting of 10,000 of language sentences. It's almost impossible. No. So definitely impossible. Okay, but if we make use of large language models, we can test 10,000 or 100,000 of sentences language experiment. That's possible. That's a good point. But we also have some limitations. We should be aware of that kind of pros and cons at the same time. Okay? And then now let's move on to the Korean examples that I have carried out so far. The first one is morphology. Okay, so Korean is the so-called the representative agglutinative languages. So there are some nominal markers as well, and then the nominal markers would be quite flexible in the morphosyntax. For example. So in this case, 저는 책이 읽었다. And then 저는 책을 읽었다. So in this case, check means book, and then this one is the object. Definitely, given that this one is the object, only accusative marker can be attached. If the nominative marker is attached to the object, that sentence sounds basically ungrammatical. But sometimes, if the predicate includes an auxiliary such as ship want, in that case, the object can be associated with two different types of markers at the same time. So nominative marker, accusative marker can be attached to the object in this case. So again, the morphology is quite flexible in Korean. The same goes for this one. For example, Juan went to Busan. Juan은 부산에 갔다. 주안은 부산을 갔다. In this case, A is the locative marker, and then 을 is the accusative marker. So in this case, both markers can be attached to the goal agent. Okay. So in this case, we can find out another way of flexible attachment in Korean morphology. So I tested this kind of morphology, this kind of flexibilities in morphology with respect to the larger language models. The problem is we found some overgeneralizations in the experimental result. So again, basically large language models work well, but there are some problems in the result. So they can understand that kind of flexibilities in Korean text, but they overgeneralize that kind of morphological attachment. Okay, now let's move on to syntax. Probably, as you know, one of the very interesting things is binding relationship, binding thing. Okay, so for example, in this case, let me show you some examples. Johnny 메리에게 자기에게 컵을 주라고 말해. This sentence means John told Mary to give a cup to Seth. So in this case, this 자기 is the reflexive form in Korean. In this case, in Korean, this 자기 can refer to either the subject John or the beneficiary Mary at the same time. Okay, so this one is the typical examples of Korean binding theory. So the reference can be either of them. Okay, so the same goes for here. I tested the larger language models can understand this kind of ambiguity in binding theory in Korean. Okay, so the relationship is this one. The major finding is larger language models can capture some semantic cues, but fail to reproduce the human preference. Okay, definitely, both of them, the larger language models can understand both of them are allowed in Korean syntax, but there is some preference between them, but that kind of preference cannot be fully captured by the larger language models. Again, the larger language models can understand the basic, the surface level Korean syntax, but they cannot understand the deep psycholinguistic patterns underlying the surface level. Okay? And then syntactic minimal pairs. Definitely, in syntactic studies, we make use of the minimal pairs. One sentence is well formed, and the other one is ill formed, even though they look quite similar to each other. Okay, and then the difference between them is relevant to the syntactic constraint. Okay, so if larger language models indeed understand the syntax, they should be able to discriminate the well-formed expressions and the corresponding ill-formed expressions at the same time. I also asked that kind of minimal pairs with respect to the different types of larger language models. The problem is, as you can see, is English-centric bias. The larger language models can discriminate the two different types of expressions, well-formed expressions, ill-formed expressions, very well with English data, but not with Korean data. It is largely because the GPT models or whatever, they have their own training data, and then as far as I know, the larger language models have more than half. Almost 49% of data is the half of the training data normally comes from the English data. That means they can discriminate, they can understand the basic syntactic constraint on English data, but not on the other types of language data, such as Korean. Okay? So even that, so this one, models show, as you can see, human-like processing aspect, but the performance reflects only surface level ability rather than some deep understanding of syntactic constraint across the human languages, such as Korean, Japanese, Chinese, or whatever. Okay? And then building upon the previous one, I also asked this one. So, if you are undergraduate student, probably you should take the syntax course, and then definitely you should take the exam. So I made use of the syntactic exam questions to evaluate the syntactic ability, the syntactic understanding of large language models in English and Korean. Okay, so this one is English examples. So Mary says that Susan lies to her parents a lot. So in this case, the question is, which one is not a constituent? So very simple questions in your syntactic exam. Okay, and then we also have some Korean examples as well. So in this case, this one is a kind of attachment ambiguity problem. 메리가 매일 도서관에 가는 친구에게 전화한다. So this sentence means Mary calls a friend who goes to the library every day. This sentence definitely is ambiguous, depending on the attachment of this every day. Okay, so in this case, I asked the large language models to understand this sentence as ambiguous, and then if they can understand the ambiguity, how can the ambiguous happen? Okay? The problem is this one. Current large language models, even if the GPT model 4.0, they cannot understand that kind of ambiguities in Korean as well. Again, the same problem here. They can understand the syntactic problems in English, but they cannot fully understand the same syntactic constraint on Korean data. Probably GPT has a kind of a syntax textbook in the training data. Definitely. So they can understand the syntactic problems, the syntactic questions more than enough, but they cannot have the Korean syntax textbook in the training data. So this kind of discrepancy happen across the human languages. Okay? Also, so building up on the findings so far, I created a kind of test suite for evaluating the syntactic abilities of human language experiments. So large language models. Okay, so it has the name KBREMP. This one is a kind of a type of data set for Korean specific syntactic evaluation. So we have 5 syntactic phenomena consisting of internally headed relative clause, multiple case marking, and then persuasive constructions or something like that. They are Korean specific syntactic problems. So we have 3,200 sentences in total for the evaluation. The answer, the finding is none of them. No current large language models, including the GPT-5, cannot pass all the eight language phenomena. That means they can pass some of them, but none of the large language models can pass the eight test set at the same time. Okay, so again, the recent large language models works really good, but they are weak in terms of syntax, pragmatics, and whatever, especially with respect to some low resource languages such as Korean. Okay? And then again, so in my idea, ambiguity would be the very important issues in understanding human languages. So furthermore, I tested the ambiguities in more detail. The first one is structural ambiguity, the attachment ambiguity. This one is quite well known. I saw the man with a telescope. Okay, so this sentence means the man with a telescope or a telescope as an instrument. Okay, and then how about this one? someone shot a servant of the actress who was on the balcony. This sentence can be interpreted either this one or this one. Actress was on the balcony or the servant was on the balcony. So this sentence is basically ambiguous. The problem is the preference. The preference differ in different languages. In English, LA, low attachment, is much more preferred, more than 90%, 70% as far as I know. In Korean and Japanese, high attachment is much more preferred, more than 70% as far as I know, following the previous psycholinguistic experiment. So I asked larger language models to understand that kind of ambiguous, and then what kind of meanings can be detected. The problem is all GPT models still choose only low attachment, which is similar to the previous one. English-centric bias in this case. That means, in my idea, the pipeline is something like that. The ChatGPT, the GPT model understand the questions, and then internally they translate the sentence, the Korean sentence and the Japanese sentence into English one. And then they process that kind of stuff, and then they translate the result once again to Korean and Japanese again. Hence, this kind of result, in my idea. Okay, and then, so this one. And then I also asked the scope ambiguity, which is a little bit similar to the scope, the attachment ambiguity. For example, this one, the professor didn't talk to every student. So this one can be interpreted as either the surface one, he talked to some but not all, or he talked to none. Okay, so, and then we also, in Korea, we have two different types of negation. The first one is so-called short form negation. And then the second one is long form negation. The same goes for this one. So the short form negation can be preferably interpreted as less inverse scope. This means this one is more relevant to the surface one. On the other hand, long form negation, this one can be interpreted preferably like this one, inverse one. Okay, so again, both of them are also the well-known and the canonical negative expressions in Korean, but their preference of the scope ambiguity differ. Okay, so this one is the example. Johnny 모든 사람을 안 만났다. This one is surface form, short form negation, and then Johnny 모든 사람을 만나지 않았다. This one is long form negation. Okay, both of them are totally grammatical, but they differ in the preference of the ambiguity, the choice of the ambiguous meanings. Okay, and then the answer is larger language models display exaggerated sensitivity in some context. That means they can understand both of them are ambiguous, but their preference is not the same as the human being, the Korean native. Okay, so that means they can understand the surface level syntax and semantics, but they cannot fully understand the preference across the Korean native speakers. Okay, and then the same goes for this one, NPI. So NPI licensing is one of the very important issues in syntax and semantics. Okay, so in this case, so this one is grammatical and this one is not grammatical, because so this NPI any is not licensed by anything in the same context. Okay, so I also make use of this kind of examples. 좀처럼, rarely. So this one is the negative operator. The negative operator items in Korean. And then if this one is inside of the same clause with this kind of negative operator, this sentence sounds grammatical. Otherwise, like this one, this sentence sounds ungrammatical, unnatural to native speakers. Okay, so I also asked the large language models if this kind of patterns can be fully detected. The answer is not so great. Okay, so the previous Korean specific BERT model, Korean specific encoder models cannot fully understand that kind of licensing of negative priority items. So the problem is they can understand the surface, the simple patterns of Korean syntax, but if the question is linguistically, syntactically, and semantically complex, the large language models cannot fully understand the difference between them. Okay, and then pragmatics. So this one, the discourse expectation. So this one is carried out with only English data. For example, this one. So Carl fixed the computer, and then Margaret paid him $50, and then the mine shut down, and blah blah blah. So in this case, as I told you before, the next sentence prediction would be quite important. So these two sentences are coherent, and then these two sentences are not so coherent with each other. So this kind of strange patterns can be well detected by English large language models. So the result is not so bad, even with the previous models such as GPT-2. Okay, and then this one, felicity condition. I also tested with this kind of things with English large language models and English data. For example, the felicity refers to the pragmatic appropriateness about the question and answering. For example, this one, John made the desk, and then the desk was made by John. These two sentences share the same truth condition. This one is a passive sentence, and this one is the corresponding active sentence. But they are not equivalent to each other in terms of the felicity condition. If the question is this one is felicitous within the given context, and then this one is not so felicitous within the given context. Okay, so if we test this kind of questions in English with large language models, we can get some very nice, very reliable result. Okay, but from here, I asked some pragmatic notions with respect to the large language models. The first one is tautological expressions. Tautology itself is quite simple. X is X. For example, Seoul is Seoul. Boston is Boston, or something like that. If I say Seoul is Seoul, I want to say the pollution, a lot of population, some complexity, high wage, or something like that. Okay. The problem is, if you do not aware of some background related to Seoul, you cannot understand the meaning of Seoul is Seoul. Okay, so this kind of tautological expressions is something like some social cultural context within our human language data. Okay, so when you say X is X, if you are well aware of the basic properties of X within our social and cultural context, you can understand the meanings full enough. Okay. Otherwise, that kind of expression sounds a little bit weird to the other person. Okay. I also tested this one in Korean to the large language models. The problem is this one. Large language models, even if the SOTA models such as ChatGPT, the GPT-4o or something like that, they struggle with programmatic inference in private meetings. Okay, so the native speakers, the Korean native speakers, normally can understand these X meanings within the given context, but large language models cannot fully understand that kind of meanings. It is largely because the GPT models do not have enough text data written in Korean and Korean society. Okay, and then this one. So honorific mismatches. English does not have this kind of expressions, honorific expressions. So I checked if the large language models can understand the honorific constraint on Korean text or not. So the answer is, I asked some 3,200 sentences about the different types of honorific forms in Korean. The result is they basically they can understand the basic usages of honorific forms in Korean, but there are some overgeneralizations. It is largely because the training data includes some daily speech data or some web-based data or something like that. So they can understand the basic properties of honorific forms, but not perfectly. Okay? And finally, this one is a kind of multimodal testing. So in these days, the multimodality is quite important for understanding and for using large language models. So I made use of this one. So I provided the large language models this kind of images and this kind of text at the same time. Okay, for example, in this case, the woman followed the man up to the stairs with her luggage in her hand. Okay, and then something should be here, and then the man shoved her hand in refusal towards the man. Okay, so in this case, I provide only this picture. Okay, and then without this one, and then I also provided this text. Okay, and then I asked the ChatGPT or the other GPT models to understand what should be here. Okay, so the problem is the recent version of ChatGPT cannot fully understand the image data. They only refer to the text data. Okay, so they can provide the correct answer very often, but the problem is they cannot look at the image data at the same time. Okay, so that means even the recent version of ChatGPT models cannot be regarded as a genuine multimodal system. Okay. Okay, that's it. So let me conclude my talk today. So basically speaking, large language models offer promising avenues for linguistic testing. So again, large language models can be used for many types of psycholinguistic and the other types of linguistic data. But before that, we need to understand the current limitation of the large language models. They can be fluently used, but there are some limitations in the understanding of the syntax, semantics, pragmatics, or whatever. Okay, so and then this one, and finally this one. So I wanted to say two things here. So in these days, I'm working on this one, baby LLMs. So as I said before, the problems of the cognitive plausibility of large language models should be the development process. So for understanding that kind of stuff, recently I'm working on this kind of data, baby LLMs. Okay, we need to understand how the large language models can be work with the language development. Okay, and then the other things, and then finally, I would like to say this one. We need to build up a kind of a concrete, a specific bridge between AI and cognitive science at the same time. So that kind of bridge should be work for the human-centered language technologies and cross-linguistic evaluation as well. Okay, that's it. Thank you so much.